Thank you everyone for attending post-lunch. So, and also everybody would be in a wish to go back after spending 3 nice days here. So still I hope to retain your interest for the next few minutes. So this is about sustainability, environmental sustainability. Generally, more than ever, this is the period, this decade, next oncoming decade is going to, sorry? Next oncoming decade is going to be a very big shift in the way the mills are seen or the way the mills are being operated and the amount of governmental interventions or the public intervention in the operations of paper machines. So it is a good thing to have a look through during the, especially on this World Environment Day. And I've tried to keep it as simple as possible so that first we understand the concepts better. So because many times the word sustainability is a very loosely used word. So many people just even taking one or two actions, they think it is part of sustainability. So it is not. Yeah. Yeah. So before looking into it, now it's okay? Yeah. So before looking into it, we have to see what sustainability means. Of course, due to limited timeline, of course, this timeline is much better than the previous IPTAs where you have to rush through the presentation. But still, sustainability is such a large word that it covers various aspects, including CO2 emissions, biodiversity losses, consumption of green products, air pollution, renewable energy, climate change, even people, and solid waste management and energy efficiency, etc. But time being, I have just some of the core thing that I've decided to take up here is about the water sustainability, because even air it includes air also, like NOx emissions, carbon emissions and all that, but that is reasonably covered by technology as of now. There's no, I don't think there is a very big gap between what we need to do and what is available. But whereas in water conservation, there is still a lot more things need to be done. So some of the common themes to see it as on sustainability grounds is water pollution and also the preserving natural resources. So that water is also a natural resource in many ways, and innovation aspect of it, which includes sustainability. So, but before all this much hype came, there was one Indian company which proved sustainability in a very humble and in a very practical way, which is Anand, Gujarat. So if you see way back in the 60s, they started not only the milk production, bothered about milk production and milk quality. They brought all the districts together. They brought the people together. They ensured the cattle are taken care of very well. So it is a totally closed loop, this one. So that is one of those few companies which showed long, long ago that it is possible to run a successful business, including sustainability. So similar way, there are still options. Only thing, by way of nature, probably the water treatment had been, since available, as long as availability was there, it was a less focused area for us. We lost some time in learning those things. So still it is possible to catch up, and still there needs to be some mindset change to accept new technologies. So that is what we'll see here. So some brief about the basic ground realities and compulsions. This is from the report of benchmarking industrial water use efficiency in India by the TERI, and also from the National Water Mission from Ministry of this one government. It's a 2-year-old report, but captures reasonably quite well on what is the current status and what are the things that are going to come with respect to water sustainability. So amongst the water intensive industries, thermal plants are the highest consumer of water, followed by pulp and paper, textiles, and iron and steel industries. Apart from just the quantitative aspect of it, existing challenges or inefficiencies in water management practices, such as over extraction, pollution, and lack of wastewater treatment, proper wastewater treatment, further exacerbate the situation. So in consonance with the pace of industrial development, with about 8% of the total water withdrawal, the industrial water demand in India has been on the rise and is expected to increase many folds from 56 billion cubic meter in 2010 to 151 billion cubic meter by 2050. So that's a huge change. And it is estimated that without water efficiency improvements, global water demand will exceed available supplies by 40% by the year 2030. That is not very far off. We are just on the horizon of it. So that's why this subject is all the more not only important, it is also urgent that for us to avoid, not much time is there for us to learn, to implement, see, and what works best for us. And there is a respective distribution of the water consumption, but this does not take into effect the density in each location. So it is an overall India-wide statistics, but it depends that some of the paper mills are in a single area, concentrated in a single area like Gujarat, Vapi or Muzaffarnagar or some places. So the disproportionate increase in paper mills in a particular area compared to what is the water condition there is not captured in this, but we will cover later in that. So integrated mills considerably higher, 30 to 33 meter cube per ton is consumed. Recycled fiber takes about 9.9 to 13 meter cube per metric ton. And at present, 73% of the paper is produced from RCF-based mills. I think this more or less matches with what Mr. Taplial also showed. Around 75 to 80% is recycled fiber. So this reasonably consumes less water, and probably there has not been that much growth in the number of new integrated paper mills also. So there is a possibility, and recycled fiber mills, the management of water can be much more easier than integrated. And of course, short-term interventions as recommended by those team, by that particular team, their side of reduced water usage for showers, and also in the long term that bringing of Sewall clarification system and polydisc filtration, and go towards approaching ZLD. But my view is that even this Sewall or polydisc filtration cannot help you to reach towards ZLD. Then there needs to be some more. Of course, Sewall, the paper mills in 50s started with Croftas and Sewalls, DAF and all that. Then in the 90s, this filter became popular. And it is quite some high time, it's 40 years since, that we need to go towards even more better technology. We need to change the gears now. So I'll explain the reasons for that while in the course of time. So this is the future indication given by them that in future the government may push you towards from 30 to even 15. That is really 50% reduction in the usage for integrated paper mill, and RCF mills again from 8 to 4, or at least not exceeding 8. So this is going to be a tough challenge, and it is coming very soon. So this is the forthcoming policy recommendations, setting up of water benchmark for industries. It is going to, we used to only talk like what is the benchmark abroad or here or there. So the government will soon come up with a publicized benchmark for a particular type of paper industry, and as well as for the area it is in. And best use efficiency to be given a legal status. And mandatory water audits by third-party auditors. These are the things that government is thinking to implement to enforce paper industry match the thing. And information management and public data sharing, like whatever good or bad you do will be shared with other people so that the knowledge doesn't remain in one place. So because like I said, we don't have much time for each one to experiment. So much about of data sharing will be enforced. and industrial site approvals to be based on the carrying capacity of the region. Like I said before, the population density of mills was not covered, so that is being covered now. That they are going to, according to the area, it doesn't matter the overall India statistics may say something, but they are going to evaluate on what is your area telling to do. And for that, the National Water Framework Bill will be done, and it is no more going to, water is not going to be a free lunch. The entire operation of the water the government does to ensure that you get the water, that they are going to free it up. The basic philosophy will be you need to pay for it, the entire process. And draft water policy, and the idea is the entire operation and maintenance cost of such a water supply will have to be borne by you. The government will not do, even though, I mean, basically all governments invite you to put a mill saying that it's an employment opportunity, it's a revenue for the state and all that. Now, this is going to supersede that. So, it's not going to be a freebie or this one. And Water Regulatory Authority reporting to the center will be there for each state, and they will be authorized to fix rates, which already I think is to some extent is in practice like Gujarat or here, but it's going to be the norm. And they will align with the overall national policy. And incentive mechanism by such water regulatory authority to those who adopt water neutrality. This is also not only punishment, it is also encouragement that they are planning that whoever falls in line will be appreciated. So now if we go into the, after this very basic, like we use paper industry, we use all types of water, surface water, underground water and municipal water in some places. Now again, surface and underground water is being used by integrated mills and recycle mills. Mostly brown craft paper mills, there are a lot of them which use municipal waters as well as underground water. And invariably, a high COD stream, in integrated mills, you have a high COD stream and a low COD stream. There is a recycle mills also low COD stream. And brown craft paper mills, they call themselves ZLD. Again, that is a wrong nomenclature. They are not ZLD. They are 100% water closed mills. So ZLD has a different philosophy. So if the key word is not zero liquid, it is zero discharge. The key word is liquid discharge, zero liquid discharge. So effluent is generated, if you see the kind of effluent when you have to balance this one. Like I say, the water sustainability covers everything, right from the where you source it from, where it transits and everything. But within the mill, that if you see that, the main three sources are pulp mills, where there are extreme chemical reactions and there are leaching of chemicals into the water. So this is where it changes the chemical structure of the water. So this is one main thing. But if you come towards stock preparation, it is like basically you take water and then if you see nature, you already have a fiber or pulp available. You add pulp, you add lot of chemicals or other things like dyes, fillers, basically it's all addition. And by increase in concentration, or other option is the ancillary units like vacuum systems, heat exchangers, where there is due to some kind of evaporation of water, then the TDS of the water increases, causing to either scale or corrode. So these are the three areas, or even in utility like your DM water backwash, your evaporator backwash and all that. So these things come to the effluent. So this is another route of different streams. So if you go back, I could be able to break through that when you talk about how to treat water, it is better to go through the same route that it is formed. Like if it is a pulp mill effluent, you have to break the chemical reactions through some means of breaking it up, the reaction part. In terms of other low COD stream from paper machines and all that, everything is added to the water. So the simple logic is that you remove everything from the water and the water will regain its composure. So you don't have to apply a different method. And the reason why I tell is the moment anybody talks about water treatment, immediately they think of RO. RO in majority of the places is not needed inside the paper mill at all. Whether through, first of all, there are industries with low volume but a very bad quality of effluent. There these kind of tertiary treatments are viable. There are industries with large water but very less impact on the water. So these also can be treated at a reasonable finance. Paper industry is one such where the volume is also very large, the quality is also extreme. Particularly, and particularly like the philosophies which we have developed, like mixing low COD and HCOD stream. Now you make it very large volume with a very medium level of parameters problem. So it becomes all the more difficult to treat. It's not viable. Having just simply putting a tertiary treatment at the end of ETP is not going to work out at all. In fact, I myself have worked out costing for nearly 4-5 mills trying to do this at ETP. Nowhere it became only a book interest. That's all. Just everybody saw it, decided it's not going to work financially, and they left it. So we propose a different methodology instead of doing the tertiary removal, and it is not necessary also because RO removes to the elemental stage every ion in the water. That much removal is not necessary to make paper. So the basic concept of treating water is, one is water is a universal solvent. It dissolves everything that is available in the world. Second, water finds its own balance, including property-wise. Like that is why when you DM water is corrosive, because you have removed certain ions from it. Then it catches that from the pipeline or equipment. It pulls it. RO water is also corrosive. So many people use RO water for machine showers. So that is also corrosive to the shower pipes. Someday you need to change. So it's not a good idea. Then when water evaporates, its constituents don't. That's what happens in evaporation or condensation. So either it leaves the material or it takes material. So then the significance of, most important is significance of treating raw water versus process or wastewater. Raw water treatment, like everybody knows, paper is 1% solids in head box. So 99% is water. And in some form, even after all optimizations, at least 50% you have to take the water in. So the easiest part is treating the raw water, the most economical way. Lot more focus needs to be given there in the treatment of raw water. You do that, whereas any other problem, physical or biological, to treat a process water takes much more money and effort. So types of discharges, you have the main, what the government defines or what the parameters you send to the central grid is mostly the 5 parameters: pH, temperature, TSS, BOD, and COD. In case where you are letting it into the river, all these 5 factors matter. And if it's farming, you leave it to agriculture, then most likely the first perception of the public is from TSS, turbidity, and color. So that is, for a farmer, that is the first impression. Of course, the nutritional value of the water, so it depends on whether this water is hurting the farm or not hurting the farm, that also matters. That's the next level. So, but at first eyesight, it is the color and the turbid nature of the water that affects them. If you're going to CETP, it's all about cost. So it's quantity, and they evaluate the costing by TDS mostly. So that is going. And 100% water close mills, like it happens in brown kraft paper. The main issue is VOC, odor, volatile organic components, and methane development. Basically, the whole mill operates like a partial UASB. Methanization happens in the open. So that's why the entire mill stinks, the paper stinks, and anything kept with the paper also stinks. Yes, and of course, water, if you make an elemental analysis of water, you can make so many varieties of cations, anions, other than cations and anions, everything. There will be a huge 25 parameters. You can make an elemental analysis. But you don't have to complicate yourself every time while talking this to that much level unless there is a specific issue. If you have to describe water, there are basically the 4 levels of description is good enough. One is the ferrous or manganese or sulfur or alkalinity that comes with the fresh water. These can impact on the color of the paper, or even some side effects like anaerobic bacteria. This can happen. And pH, temperature, color, calcium hardness values, TSS, TDS. This generally, and turbidity, conductivity. These generally describes anybody if you tell these parameters can visualize what the water is going to look like. And TABC, that is total aerobic bacterial count, and total organic carbon, and BOD, COD. These describes the biological nature of the water. And MLSS, MLVSS, and VOC or CH4 methane, these things are especially limited to ETP. So in ETP parlance. So generally you can describe the whole scenario inside the paper mill with this simple chart. So this we already covered already, like scaling or corrosion or odor from volatile gases, and color and chemical reactions, and also particularly if the same water, raw water, especially if you are using it for your housing, and this one, then the taste for your mill workers also, the taste also matters. If it has too much iron or manganese or anything, taste can be bitter. So we have to see that. So when we go to treatment methodologies, wherever we go, many places that we went, one of the first primary obstruction that we see is there are no separate lines for human consumption, whether in the housing society or inside the mill. Because here the treatment philosophy is different. Drinking water is defined as potable water. There is a certain norms for potable water, and you have to meet it. And if you have to do the treatment, many places we find there is no difference. And second thing, if the mill water has a more difficult problem or something, you need a bromine treatment or something like that, you can't do it because bromine cannot be given in the drinking water, for example. So even if maybe some mills were established many decades ago, so it doesn't matter, but I would say that still it is worthwhile to review your, after all it's a matter of pipelines and this one, it's still worthwhile to relook at the issue and have a separate treatment line for potable water and mill water. So there will be two different treatment regimes for these. And mill water, then STP also, because housing society, STP also you can recover, and with the ultrafiltration treatment you can give it, you will use it in process water also, cooling towers. So this we already covered. I'll skip through. No, lot of understand, but there is, I mean, here we are just talking about the principles here. But one thing I would, the main important key from last 5 years I have been doing research on this is don't take COD at face value. Because what happens, BOD or COD, don't take it at face value. All the numbers look very large for any effluent treatment. But if I go back to the same principle, that's why I marked on how the effluents are generated. So if you divide that COD into, like I said, in paper machine majority, you add something into the water, right? So now you filter that paper machine process water with a Wattman or even a normal filter paper. You remove all the possible suspended particles or even colloidal particles out from there. Then measure COD. So if you remove the suspended COD, then your COD level drops very down. I got nearly out of 5-6 places I did exercise. The average was about 55 to 60% reduction in just removing the suspended colloidal. How we will remove that? How we'll remove that we'll see in the coming slides. So if you do that, so don't get. I mean, this happens not only in paper, it happens in many industries. In F&B, there will be the normal BOD, COD will be around 5,000 range. But when they do the CAP cleaning, it will go to 65,000. But anybody who designs the ETP there, because if it's a one-page inquiry, we have this information. The general water treatment people do not know what the process industry is facing. They will immediately they will take the highest number and design an ETP. And ETP is one area where probably the only area in the paper mill where over design is extremely bad. You can even manage a CO ATP which is slightly 20% less capacity, easily manageable. But if it is 50% more, where I have seen in many places, it is, we can't fault them because some mills are very bold. In those days, the calculations were different, or with the water consumption levels was pretty high, 50, 60 for integrated paper mill. So even a clarifier, this one, then so many efforts had been taken to reduce the water. But today that 3-hour retention time in clarifier has become 12 hours, which is actually very bad for clarifier. So that's the way we look at it. So the core principle is to not be taken away by the first impression of COD. So you need to do this exercise of removing the suspended BOD COD. Then it is a every mill will come into a very manageable situation. So how to remove that part is practically we will see here. So the ways to approach water conservation is reduce, reuse and recycle. Of course, reduce is whatever you see at first sight, wherever it is leakages, spills, overflows. So these things you have to stop irrespective of what it needs to correct it. So some places the tank overflows, you got to decide. And those are exactly the target areas where you can conserve, and instead of sending it to ETP, overflows. One is the bad process thing happening. Second thing is if you reuse it, again ETP load will also come down. So those are the real target areas for reduce or leakages or anything. And always have to have a check on the consistency. Whether if you are running something at 1.5% consistency, really check and experiment whether do you need that 1.5%, why not at 2%. Every small change will help in reducing the water in the process. And reuse is many people, there also a lot of misconception happens because somebody from top management the force that just reduce this much in this area. So they say they use the water for some other purpose. But this is not reuse, this is rerouting of the water. So reuse means you have to treat that water, bring it as close to fresh water as feasible. Then only it is reuse. So if you just directly take it and I'm using clarified water for something else, it's not, it's a rerouting basically. And even most of the mills operate the wet end at a higher conductivity level because reusing this backwater for even dilution. Now you are looking at it only from the water perspective. But you see from the solids perspective, how much dead material is circulating. In that case, you are increasing the surface charge of the constituents, you are increasing the conductivity. So again, because of this, all the wet end chemicals will increase, sizing, retention, everything will be higher. So there has to be a method to remove these solids. If you want for dilution, you use for dilution, but it should come back very close to freshwater norms in terms of TSS or colloidal solids. So that will be a very much saving. Not only the additional benefit will be the less addition of chemicals, which again in turn reduction of COD, everything. So that is this misconception should be removed. Rerouting is different, reuse is different. Reuse means there is always a process where you treat the water before. And recycle should be the final option after, it's in the same order you have to go. First reduce, then reuse, then only you should go to recycle. Because recycle is an expensive option. You are trying to change the structure of it. CapEx and OpEx both will be involved. So naturally you have to do this better. Or if you employ recycle and then someday later you get some other idea you can do without it, then this will be at extra capacity, same like ETP. It will be operating at 50% capacity, then also it is not economically viable. So this is the thing, basically you have to keep the margin as close to possible to fresh water. So zero liquid discharge, again there are a lot of misconceptions here. So which is the key word, zero or liquid or discharge? So all this is a confusing term here. So it is not about discharge. This is what the brown craft mills do. They just don't close the gate and say, yes, it's not about discharge, but that doesn't become zero liquid discharge. So so no discharge exists, but it's basically zero liquid discharge. But in the sense, it will be turned into a solid discharge. So that is the real definition of zero liquid discharge. So something has to go out of the mill. You can't forever take everything inside that comes through raw water or through some other raw materials and all that. So something has to go out, and that material has to be a solid discharge.
Not necessarily that the solid need to be discharged. Because you see, with improvement in the retention on wire,
Hmm.
so your solids will remain on the with the sheet.
Yes.
And that needs to retain.
Yeah.
Maintenance.
Yeah.
Gas water with the cake. We always try as a paper maker.
Correct. That is it.
We always try to retain as much as possible
Yes.
on the wire, so that your backwater consistency will be less than or around 0.1.
Yeah, correct. So that's what I mentioned, that when you do water conservation, it is not, you should not worry only about the water part of it, not the Q part of it, but also the solids part of it. And this solids comes in all the stages, right from the way you start the process. That's what I said, we have to challenge at every process. So is this what we can do, or we can do better at a higher consistency? Then you reduce either the liquid part of the requirement of water intake itself. That is one approach. The other approach is you make it far more treatable by using this kind of filtration process.
We are claiming that it is zero liquid discharge. They say that we are retaining the solids on wire. Okay, whatever backwater comes, because we cannot hear anything.
Not audible? Yeah, I think it's off. Looks like. Yeah. Okay. Yeah.
So solids are all retained with the sheet, and backwater is closed.
Yes.
Here the only problem is the conductivity,
Yeah.
because it multiplies.
Yes.
So for that, some top up is required.
Yeah.
So otherwise,
No, no, I am telling ZLD in the sense in the last part of the ETP, the final discharge part of it. You understand? So that is feasible. In many industries, they have only solid discharge. Basically, ZLZ points to that. Basically, solid discharge. In solid also, there are two varieties. One is with a high calorific value, I think something about 3,500 or something. That is considered a hazardous solid. The remaining less than that is non-hazardous. That only disposal norms vary. But several F&B industries or other industries, they do total ZLD. So I'll be touching on that also. So, but this is there. The process is not at one place, definitely. The process is right from the beginning of the mill, right from raw water intake to raw material intake. You have to check and challenge each process, whether is this or can I do better in terms of, and when we talk about water conservation, it's not only about water, it equally solids has to be considered. So basically, the solid discharge. Now only we have started talking on this, but to achieve this will take some more years and understanding, because this is also a bit tricky part in going towards this in ZLD, because any mistakes can cost you financially pretty high. It's not moving. Yeah. So basically, steps to ZLD is reduce, reuse, recycle. All these have to be in the same order. Recycle. Then what is special in adding to it is finally when you come to recycle part of it, or the final RO stage of it, it's not just one stage is enough. You have to do multi-stages, either 2 or 3 stages, again to reduce the water volume out of the RO plants, final. Because any ZLD is always cost is per meter cube of treatment. So you have to reduce that meter cube part of it, and the final RO reject should have a very, very high TDS, beyond 40, 50,000 or even 1 lakh. Then only ZLD will be viable. So to do that, recycle. Then there are certain liquid to solid conversions through ATFD, that is generally for small capacities. In terms of for a very large mill, probably you will need like a crystallizer. Crystallizer is like a large vessel with a very special steel, and it is at high vacuum, and they spray the, reduce the partial pressure, spray the discharge, and then it becomes a solid discharge. But it's very expensive because the steel, very demanding chemically for that steel to handle that. It's not probably even made in India, you have to import it, then pretty expensive, the amount. Plus all ZLDs need, like same our recovery, they need evaporator. Evaporator stage, then only, so that's what I put, recycle concentrate. Then you, first of all, you concentrate it in the RO plant, then you concentrate it in an evaporator, either MEE or different means. Then finally to crystallizer or ATFD. And both evaporator and RO these ATFD or crystallizer require steam as well. So you have to provision for the steam availability as well for this. So that is just spending, like in paper machine, all the steam is cost. So that is why the margin of error is pretty less. You make a mistake, you put a large size capacity, then you will spend excessive. And so these were pre-treatment, you have basically capex and then replacement membranes in the initial stages. Ultrafiltration or RO has to be changed, membranes have to be changed every 3-4 years. So it's a repeat capex, then operating expenses as well. And the second or subsequent stages of RO, you have to use seawater membranes which are expensive. Then steam, also continuous requirement in ME evaporators or ATFD or crystallizers. So these are all cost part. So our entire goal is to do the water balance right and see to it that the final unsolvable portion, the limited portion of water comes here to this stage. It can be very high on solids, which is actually good. So compared to the first slide, this is the definition of sustainability, that it not only needs to cover your purpose, but it also has to look after the universal good around your area. While also comparing, everything is included, social, economic and environmental conditions, not just environmental or anything like that. So we have to see to it that it serves everyone. So how do we do it? When we do it, the first thing is you need to take a stand. The mill should have a particular vision, a clarity, like where are we going to be in the next 5 years. It should be very clear. Then what is the motivation for it, whether you want to really do it for the environment, or even it could be for your branding, or it could be for a credibility that we, like apart from everyone else, I make paper with the lowest water consumption. So that is also fair enough. So any kind of motivation is good enough. And so you should have a very clear vision, and you should not be constantly changing from it for like 5 years or 7 years, whatever you decide. And mission is breaking down of that vision into manageable parts. And goals is immediate. Of this, all of the whatever actions you decide to do, you pick a few smaller items to do for your motivation, finish it within 3-4 months, evaluate it for another 3-4 months. If it is in line and falls within your balance, proceed to the next. So these are short-term annual goals, and this also gives you a flexibility to work out your capex distribution through the stages. So basically, once you do a complete mill audit, you can, your vision also, you can break it. Mission, you can like just do it opportunities, whatever is easy with a little expense, easily doable, you can do it. Then there are some intermediate opportunities which usually form the large part of the story. And there are capital opportunities. You have to invest at some point to do this. So, and that returns, as you go up through this, the returns will be going lesser and lesser. But you have to do it to complete the line. And low return opportunities. Finally, it will come to a stage, certain things need to be done to just close it, but it's not going to give you great return. But if you have to close the loop, you have to do that also. So, but you can mark it, then we assign priorities. When would you want to do all this? You can stretch it out. And implementation schedule. So it's the same thing, the amount of effort and returns. major step whenever we try to do something is, first of all, lack of measurement. Some mills may have very high focus on water, like the basic number. We are at 20 meter cube per ton, I want to come to 16. But if you really go and measure, like you just split according to their departments, pulping or bleaching or anything, you will not get a real measured number that what is the water coming into that plant, what is the water coming out of, going out of the plant. This is a very basic thing to fix it. Just like any financial audit, you need both your credit and debit properly to, at each stage, to find where things are going wrong. So this is very, very important, measurable. Many people, it's a lack of awareness also sometimes, because like I said, maybe if it is a 10-inch pipeline going out, people may think this big flow meter, if I buy, it's going to cost a huge amount. Not necessary. Today there are things available like a velocity-based flow meters or anything less than 50,000 rupees, 20,000 rupees. Maybe the accuracy level is not high, but good enough to do a water balance. 5-6% this way doesn't matter. So, but we can still do a good balance. So measurement is, changed. Yeah, measurement is a very key to this one. So very all critical points, we need to have measurement, this one. So it's important. And sometimes we also carry, when we do audit, we have a ultrasonic flow meter, where if nothing is there and they say some discharge is going, we just fix it there. Within 5 minutes you can take the flow for that. Then you take it to some other spot also. Multiple spots can be done with one flow meter. So those are also available now, ultrasonic flow meters. You don't have to fix there. Time over. Okay, just give me a few minutes. Then the mistakes and chemical or mechanical inefficiencies and ability to create a good water balance. So finally we'll be arriving at a water balance. And like I said, the final mill sustainability is to section wise. You bring in sustainability, like you assume each section as a mill, particularly as a mill. Then you do the sustainability actions. So then all the sum of all this will result in a better coordinated mill. Yeah, so normal roadblocks, so this happens, this is practical, cannot be avoided, but certain times we need to relook at this. So probably the paper machine team would have done a lot of chemical trials, and they would have just stabilized 6 months ago some on a good chemical program. And now for the sake of water, you tell them instead of 0.1% backwater, why don't you do 0.05? So then they have to relook at the whole issue again. So sometimes or use some other tools, but needs to be done, unfortunately, because this comes under the whole story, that total water balance sometimes. And new technologies, so sometimes we are resistant to accept new technologies. Naturally it comes, so wherever references and all these things matter. So then capital investment, so should I invest now? Of course, there is a phasing. Once you work out on the water balance, we decide when to invest. What are the other things you do before that? Low investment areas. Finally, but at some stage you have to deal with the capital investment, and that has to be done. So these are general mental blocks which are there to finally reduce the water balance. It's okay, I'll skip this long story. So basically you look at it like a project management. You visualize, I mean, this is all in the book also, in the article, so you can see that. So basically you have to look at all aspects and do it like a project, basically covering all aspects. And whatever is the current water treatment areas, we have to see how you can increase the efficiency of it. Every individual application, every individual area needs to be challenged. What better can it do than now? So at every stage you have to slowly add the little increments of water savings back into the water balance. No, I think this is wrong. Yeah, so now there are certain typical blocks which we enter into, like many mills have this concept of LCOD stream, low COD stream and high COD stream, finally managing the discharge norms. Now if you go there, like wherever is the easy options, most likely you will find more in the low COD stream. Now if you do that, you will, problem is they'll say, no, don't reduce this water. So I cannot meet the discharge norms with the high HCOD. So these kind of obfuscations also occur. This needs to be worked out, how we bring it. So both individually, high seawater stream and low seawater stream has to be tackled individually. Something needs to be done. So what do we do? Huh? Yeah. Okay. Okay, fine. Because originally it showed 3:30 or something, right? 3, then some Q. Huh? Acha, you want to shift it? No issue. Okay, fine. Okay, okay. Yeah, thank you. So, I mean, it's in the book, article is in the book, you can go through, or you can always contact me for further.